Okay, so this one actually caused a little bit of trouble. One of the things that got people in trouble, and it may or may not have been a first step, was trying to divide some sort of trig function out of both sides. So, for example, you could have right from the beginning decided, oh, well, I see a tangent beta on both sides. I'm going to divide it out and say that I just have 2 cosine beta equals negative root 3. And I don't know why that decided to go so spotty. There we go. You can solve from there, and you do get some correct solutions, but you are missing some solutions. You're missing the solutions that you would have gotten if you hadn't divided out the tangent of beta. So I would just say as a reminder that if you ever divide out something that includes your variable, you very well could have lost solutions that were possible for the original equation. And the opposite is true if you ever multiply in something with variables, like you multiply both sides by an x, you could introduce an extra solution that wasn't actually possible. So if you're ever tempted to do that, what I would do instead is move everything to one side and factor out whatever you're tempted to divide by. So that's how I'm going to approach this. I'm going to say I have 2 tangent beta times cosine of beta. There we go. Plus root 3 tangent beta equals 0. And then I can factor that tangent out. And that leaves me with a 2 cosine of beta plus root 3. And that's all equal to 0. I will point out here that some people switch the tangent to sine and cosine. That is totally fine. You'll have to do something similar even if you switch to sines and cosines. You'll at some point have to factor out, I think it's a sine if you do it that way. But switching to sine and cosine doesn't actually get me fewer trig functions, because that's the whole problem is we don't ever love having tangents and cosines in the same equation. Switching to sine over cosine for tangent does get you another cosine, but it also introduces a sine. So it doesn't necessarily make it better. And that's something that I think about when I'm thinking of starting to switch to sines and cosines is it actually going to make fewer trig functions, or could I maybe factor to separate the two? And that's what happens here. I have tangent beta times the stuff in the brackets equals 0. That means that either the tangent beta has to be 0, or the 2 cosine beta plus root 3 has to equal 0. That tangent beta is already ready for the unit circle, so I'm going to work just a little bit more on this other equation. I'll subtract the root 3 from both sides, and then I will divide by 2, and I'm happy to see some special values cropping up for both of these. So if I draw my not very pretty unit circle, I want tangent equals 0. That means slope is 0. So that actually forces me to go right along the x-axis. So 0, pi, 2 pi, 3 pi, negative 2 pi. Any of those will work. And then cosine, that's an x value. If that equals negative root 3 over 2, that's going to put me out here towards closer to the x-axis, towards the left-hand side of my circle. And those happen to be pi over 6s. So this is a 5 pi over 6. And then at the bottom, my circle looks a little funny. So it looks like it's down low, but really it's up here a little closer to the axis. So it's right at 7 pi over 6. So it's just pi over 6 above the point negative 1, 0, and pi over 6 below it as well. So we're supposed to describe the entire solution set. For tangent, we're going to find that beta has to equal, you could just go k pi, 0 plus k pi, or pi k, whichever order you like. You could also do pi plus k pi. You could do 2 pi plus k pi. Pick any one of those, but it's kind of neat when you do 0 because then you're just writing k pi, any integer multiple of pi. This one's a cosine again. I think maybe didn't all have cosine for that one, so you might not be able to do plus or minus, but again, whenever I can get away with it, I love doing this plus or minus. So I would say plus or minus 5 pi over 6 plus 2 pi k, but it would be totally fine to do 5 pi over 6 plus 2 pi k, comma, 7 pi over 6 plus 2 pi k. So I'm not super picky about you doing the plus or minus. It's just something that I like, so I do it. And that looks like a great solution set. Just make sure you're using that kpi notation to catch all solutions, and you should be in good shape. Remember that you can do this instead of dividing out a function, move everything to one side and factor it out.